Okay, Math 3. Today we're going to talk about logs and log equations and how to go back and forth between log functions and exponential functions. So if you look right here, do you see here you have a log function and here is the same exponential function. They mean the same thing. So this log, this is called the log's base. So what happens is that the base of the log ends up becoming the base for the exponent. Okay? The answer part on this log is the exponent in the exponent equation. And then the answer of the exponent equation is the value that's at the end of the log, the end value. So they kind of all go together. And what happens is we're going to kind of practice this and you'll kind of get where the numbers go if you keep practicing it instead of looking at here where they're connected. Okay, so on this first part, what is the base? The base is 5, okay? And then the exponent would end up being 3. And so if you were to write this in exponential form, we would write this as 5 to the third power equals 125. And you notice here, this actually makes a true statement. 5 to the third is 125. So if it doesn't make sense, then you probably put the numbers in the wrong spot. Okay? So all we're going to do on numbers 1 through 8 here is just change them into exponential form. Okay? So on number 1, we would write this as 6 to the third power equals 216. So it's always the base of the log. This number here is your exponent, and this is the answer. Okay, so 2 will be what?
4 to the fourth power equals 256.
Perfect. Okay, and then for 3?
5 to the 0 power equals 1.
Good. Okay, remember that anything to the 0 power equals 1. Okay, number 4, it's going to be 2 to the negative second equals 1/4. And just making sure that this makes sense, if you think about it, anytime you have a negative exponent, remember we make it a fraction, you bring it to the bottom, so 1/4 is a true answer. Okay, so here you just have letters. How would I write that? Good, r to the m equals n is correct. And then number 8. Perfect. Okay, pretty easy, right? Oftentimes, it's much easier if you see a log equation. You change it to exponential equation, and you're able to solve it. Okay? Down here, they're kind of showing you the two problems. One's in log form, one's in exponential form. And so again, we're just going to write these in exponential form. I didn't realize I kind of did the same thing twice. Okay, so this would be what? 5.
5 to the 1/2 equals 5.
Good. And then number 2.
3 to the negative 2 equals 1.
Perfect. Okay, any questions? Okay, this next part on the back, and there's only a few examples on this one, because more often than not, you change from logarithmic form to exponential, not the other way around, but sometimes they want you to. And so we're going to change these into log form. Okay, so you would start by going log, and whatever the base is for your exponent, that is the same base for your log. So this is going to become log base 2. And then the answer part, 32, goes next to here. And then that equals 5. And so I always kind of like double check because changing to exponent is easier for me than changing to log. So I'll double check and be like, okay, yeah, 2 to the 5th equals 32. And know that I wrote it correctly. Okay, so this next one would be what?
Log 2, 10. And then
Log base 10.
log base 10.
Good. Of 0.001 equals negative 3. We're going to talk about this at another part, but base 10 is basically your standard base. And so, you know how when we have an x, we don't always write a 1 in front of it? We automatically know it's 1x. And so logs are the same way. Oftentimes, if it doesn't have a base, it's base 10. So if it is base 10, mostly you won't see it written. It'll just be log 0.001 equals negative 3. The only time that they write it is when it's not 10. Okay, and can you guys do the last one? What will it be?
Log base 7, 49 equals 2.
Perfect. This is gonna get, if you look at the bottom, see how you have, there's some boxes down here with special log rules. One thing with logs is there is kind of a shortcut, and I'm gonna show you right here. Do you know, how could I change 49 to be base 7? 49 is 7 to what power? Second. So I could take this here and rewrite it as log base 7 of 7 to the second power. And when these match, when your log base matches and the exponent here matches, these cancel out and your answer is just 2. And do you see how these are the same here? How this is 2 and this is 2? And so it's just a shortcut of getting an answer. But we'll kind of go through it again here. So another way, you could do it this way, and if you notice, this problem and this problem right here match. Yes? But for some people, they don't quite see it this way sometimes. And so the way to actually solve the log equations is you would start by setting the equation equal to x. Then you would change it to exponential form. So how would I write this one in exponential form? 7 to the x equals 49. Okay, and then this goes back to even what we were doing yesterday where we would change these to have like bases. Okay, and so 7 to the x equals, and how could I write 49 as base 7? 7 squared. And once you have like bases, that basically tells you your answer. You drop the bases and you get x equals 2. So we can get the same answer a few different ways. Okay, so we're gonna try this one. First thing you wanna do is set it equal to x. Then we are gonna change this into exponential form, and that would be what? Good, 3 to the x equals 1 over 27. Now, since I have a base 3, I wanna try to change this to be base 3. Okay, and so how could I write 27 to be base 3? 3 to the third. But right now it's in the bottom of the fraction. How do I make it so it comes up? So 3 to the x equals 3 to the negative 3. Do you guys agree that 3 to the negative 3 is the same thing as 1 over 27? Yeah. Anytime you have a negative exponent, you make it a fraction, bring it to the bottom. Okay? And so these would cancel out. Sorry. And your answer is x equals negative 3. Or your answer is just negative 3. It doesn't have to be x equals. Yes?
So how do you, like on number 1, how do you like 7x equals?
So whenever they're wanting you to find the answer for a log equation, you can always just put it equals x.
Okay.
Because that's what I'm solving for. I'm trying to find the answer to this. And then change it to exponential form and get like bases and solve.
Okay, but how do you get it to like 7 as x is an exponent and then equals 7 just squared?
Do you understand that once I put it equal to x, when I change it to exponential form, it goes here? And then what you want to do is, since this has a 7 in the base, you want to change this to have 7 in the base.
Okay.
And so we know that 49 is 7 squared. Once these are the same, you can cancel them out, and those equal to each other. They're set equal to each other.
Okay. Thanks.
Okay? And we kind of went through that on that worksheet we were doing yesterday too. Okay, so there are special like shortcuts for log equations. Some of the shortcuts you kind of need to know. Some of them you don't have to know because you could always set it equal to x and change to exponential form and solve that way. But one of them is that when you have log or b to log base b of x, the answer is just x. So basically, anytime these match, this number and this number match, these cancel out and your answer is just 27. Also, And you saw how I did this up here too, where I had log base 7 of 7 to the second power, and those canceled out and I got the answer of 2. Whenever these match, they cancel out and your answer is just 5. Okay, and going the long way on this one for just 1 minute, if I put equals x and I go 3 to the x equals 3 to the 5th, because I would take my base of 3 to this exponent and it equals that answer, you can see that the 3's cancel and you still get x equals 5. So you could solve it either way that makes sense to you. On number 3, they're missing a base for the log. But we know that anytime it doesn't say a base, what is it? 10. So this is 10 log, oops, sorry, I didn't kind of write this right. 10 to the log base 10 of 2. So again, since those match, the answer will just be 2. Can I change, can I change this to be base 6? Yes, it would be what?
6 squared.
Log base 6 of 6 squared, so that means my answer will just be 2. Okay, on 5, could I change that to be base 5? 125, is it 5 to some power?
Yes.
It-
is 30.
5 to the 3. And since there's an x here, you just put the x and the 3 together because they're both in the exponent part. And so that means that you would just cancel these out and the answer is just 3x. Okay? This one looks confusing, I feel like sometimes. And if you forget and you're not sure, always put equals x. And so if I change this to exponential form, what will I write? 4 to the x equals 1. What value would need to be in there for x in order for this to equal 1? 0. The answer is 0. Because anything to the 0 power equals 1. So basically, anytime you have 1 in this spot, it doesn't matter what your base value is, the answer is 0. And this goes back to one of your special logs. But if you don't have to remember that because you could always solve it this way. So you have to remember, though, that any number to the 0 power equals 1. Any questions? Okay, moving on. Okay, so these ones, they want us to simplify. Do you know on number 1 what it would end up changing to? So remember, if no base is shown, it is base what? 10. So that means that this is really log base 10 of 10, and if 10 doesn't have an exponent, the exponent is actually 1. So what is that answer? 1. What would you do to rewrite this one? 1,000 is what?
10 to the 3rd.
And 10 to the 3rd, good. And if it's a fraction, that means we're going to make it as?
-10, or 10 to the -3rd.
Good. So this is log base 10 of 10 to the -3, so that answer is just? -3. Questions? All right, this next part, all you're doing is going to change it to exponential form and then try to solve. How would I change number 1?
You have 3 to the 4th equals x.
That's right. What is 3 to the 4th power?
81.
Good. X equals 81. Okay, number 2, how would I rewrite that?
2 to the 5th power.
Equals x, so that means x equals what? You,
2.
good. I'm like, you guys should know that one. 2 to the 5th. Okay, how will I rewrite number 3?
3 to the x equals -3.
Okay, is there any exponent value that I could put here that would end up making this answer -3? If you do -1, it actually changes it to what? 1/3, right? And so this one is no solution. Anytime you have a negative in this spot, it's no solution. So I'm just going to put no solution when you have an, I'm not going to write out, but if you can do an arrow or whatever. So anytime you see a negative there, the answer is no solution. Okay, number 4. We're going to write that as how?
2 to x equals 2.
And what could I write 2 to what power?
1.
1. So what does x equal? X equals 1. So once you have common bases, you cancel that out, and you just have x equals 1. Okay? Number 4, how would I rewrite that? X to the 2 equals 64. Now, just as we try to get like bases, you also can try to get like exponents, so then you get the same base. Does that make sense? So is there something that I could change 64 to that would make it a 2 exponent? Good. So x squared equals 8 squared, which means that x equals 8. Okay, number 5, we would rewrite that as
1 over 25 to the negative 1 equals x.
good. Okay, what happens when you have a negative exponent? You flip it, right? So this one, the negative exponent has it as a fraction. So when you flip it, it's going to end up becoming 25. And what is 25 to the 1/2 power? What does that mean? I feel like you guys should know this. Very good. Okay, I'm scared. Okay, yes, the square root of 25, which is 5. So that's my answer for number 5. Okay, number 6, what am I going to do? 3 to the x equals 0. Is there any value that I could put in for x that will give me an answer of 0? No, because if I put in 0, I'm going to get 1. So guess what this one is? And guess what? Anytime you have 0 in that spot, no solution. So if you have a 0 here, or if you have a negative in the spot, either time you have these, the answer will be no solution. And if you set it up, hopefully you'll see the equation and know that it's no solution. Okay, number 7. X to the negative 1 equals 4. Okay, this one for some reason people get confused on it, but my hint would be, what would you do in order to get rid of a negative 1 exponent? What could you do?
Flip. Or I don't know. Oh, you could times that by a negative 1 exponent.
Exactly. You could raise both sides to the negative 1 exponent in order to eliminate the negative 1. Oh yeah, good job. Okay, so, because negative 1 times negative 1 is 1. And so, but whatever you do to one side, you have to do to the other. So we end up getting x equals 4 to the negative 1, which means that x equals 1/4. Yay! Okay. Is all this pretty good? Okay. Now, was there a question? Ask me.
So which one was it? Okay, so number 4.
Yes.
Number 4 on the left side, not on the right side.
Oh,
When you
that's
get
funny.
when you get to alike exponents, those cancel each other out, and then that's why you get 8, or x equals 8.
Yes. So either you're trying to get common exponents or common bases. More often than not, you're getting a common base.
Okay.
Okay. Another way though that you could have done it, I guess, you could have taken the square root of both sides. But x will not be, if you're taking the square root of both sides here with logs, it won't be plus or minus because you can't have a negative base for a log. Okay? All right. So there are going to be times that when you change this to exponential form, you're going to get something that doesn't make an exact answer. So see here how you have, okay, sorry, let's start back here, A. How when you have log base 2 of 10, if we set that equal to x and we change that to exponential form, you would write that as 2 to the x equals 10. Well, there are no exact answers for 2 to the x equals 10. I know that 2 to the third is 8, and I know that 2 to the fourth, or sorry, 2 to the fourth is 16, And so that means that my answer for 2 to the x equals 10 has to be between the numbers 3 and 4. Does that make sense? And so oftentimes, and part of me feels like you might see this on your state test, is that they're going to have you approximate. So you have to understand what's happening here. And so on B, if I put this equal to x, I change it to exponential form, I get 3 to the x equals 25 to find the best answer. And you can just kind of go through. 3 to the first is 3. 3 to the second is 9. 3 to the third is 27. So that means my answer for x, my exponent, if you're looking here at the exponents, has to be between 2 and 3. Does that make sense? Now, even more so is that is the exponent, would it be closer to 2 or closer to 3? So if they gave you like a couple answer choices, like let's say they had 2.3 and 2.7, if you're like choosing multiple choice, which one would be the better answer? 2.7, because it's going to be closer to 3.
Wait, why is it closer to 3?
Because 25 is closer to 27.
I'm doing 10. Okay. JK.
Okay, we're good then?
Yeah.
Okay, perfect. All right, any other questions here? Okay, so we're going to practice a couple more like that on this next page. And so the first thing I would always do is say equals x, and then we change to the exponential form. What is it in exponential form?
7 to the x is 9.
Good. And so we know that 7 to the first is 7. 7 to the second is
49.
therefore
It's gotta be closer to 7.
between
1,
1 and 2, but of the 2, it's closer to 1. You guys are super intelligent. Okay, number 2, I'm going to give you about 20 seconds. You try it on your own. So first thing equals x, change to exponential form. Okay, are you guys good? Okay, so when we put equals x, this became what?
It became 3x equals 200.
3 to the x equals 200. So, you know, on all these other ones, I've started at 1, but I'm not going to start at 1 on this one because we know it's not even close to 1 right now, right? 200, so I'm just going to go 3 to the third is 27. 3 to the fourth is 81. 3 to the fifth is, and so therefore the integers are between what?
4 and 5.
And on this one, it would be closer to 5. Okay. Questions? Okay. All right. So the last thing I'm just going to briefly talk about is that logs can change bases. Okay. So if you have something like log of A over C, you can end up, you could have log base 6 here or 4. You can change them to different bases, okay? There's also one thing that, and I'm going to show you how to do the changing of bases here in 1 minute. This right here, this ln, is called a natural log. Why it's ln and not nl, I don't know, but that's just the way it is, natural log. A natural log, ln, is always base e. E is like pi, okay? And if you look on your calculator, there is a button that says e, okay? E is dealing with natural logs. I just want to make sure that if you see this on your test that you have at least heard it before. Okay, so it says to rewrite the following using the change of base formula, okay? So if you look up here at this change of base formula, if you have a log, see how it says log base C of A? the base goes to the bottom. So the base C goes and makes a regular C, and then this value stays on top, and then you just put whatever base value you want, any base that you choose. So if I'm changing log base 5 of 7 to log base 2, I'm going to write this, and I normally will rewrite it first as log over log. The base part goes to the bottom, B and B, and the 7 stays on top, and then I just do the 2 for the base. That's it. So I'm going to give you a minute to rewrite number 4. So again, you'd write it as log over log. You could write base 10 here, but do we have to write base 10 when we're changing it to base 10? No. So either way is fine. And then where does the 2 go? On the bottom, and the 3 goes on the top. So it could be written like that, or if you want to write the 10, you totally can. It's just, like I said, we normally don't write it.
So it's always going to be written like how it is for number 3 and 4?
When you're changing the base, yes.
Okay, so it's going to have that little number and the big number?
Yes. And so, and the little number is stated as your base. So log base 2 of 5, log base 2 of 7. Okay, now, just like I changed it from this to these, right? You can go backwards. So basically going backwards, you can cancel out, if you had something like this, you could cancel out the 10s, and the 2 then becomes your base, and you have log base 2 of 3 to get back to there. So how could I end up changing number 5?
Change it to log, set base 7, 8.
That's
base
it?
5.
No. So you cancel out the 5s, and you're writing it as a single log. It'd be log base 7 of 8. Okay, so that means on 6, how would we rewrite it?
Cancel out the 2's.
Mm-hmm.
Log base 10 of 6.
Good. So you can write that as log base 10 of 6, or do I have to write the 10?
Log 6.
Log 6. Either one. Okay, any questions?